Hello, and welcome to the Usefulati, the show that turns the writing of the world's most useful people into audio episodes you can listen to on your drive to work. Today we have a blog from Casey Handmer, the founder and CEO of Terraform Industries, a startup that's turning water and air into carbon-neutral natural gas with solar power. See the description for more, and let's jump in.
This post is a follow-on from my blog on optimizing resumes and my blog exhorting people to build more hardware. One part of my job running Terraform Industries is recruiting, so I am privileged to meet, screen, and hire some of the best engineers who have ever lived. In my work life, I am surrounded by living, breathing technical encyclopedias who mostly build machines that fix global warming but sometimes indulge my questions. Yet extraordinary engineers are incredibly rare. Almost every week, I will meet someone with a great track record and exceptional technical skills, but there is a key area of competence which is evidently not taught in schools and only learned accidentally on the job. Even stranger, this skill is not difficult to learn compared to thermofluids, and its scarcity negatively affects every project ever built. Hundreds of books have been written on it, many of them excellent, and yet most engineers remain blissfully and even studiously ignorant of it for their entire careers, usually to their direct detriment. Reader, I refer to a dedicated study of the coordination problem. Companies exist to produce a product or service that generates more value than it costs to provide and whose delivery increases, incrementally, the net worth of the entire world. For example, Apple produces high-end computers and phones which are, despite their high price, regarded as necessities by millions of people all over the world. Their use usually brings their owners joy and productivity, making Apple one of the most valuable companies in history. What Apple does is so hard that it has no competition. Of course, there are problems that can be solved by sufficiently talented individuals or even small teams, but almost by definition, the really nasty persistent challenges require enormous resources to address, including lots of people with a wide range of skills as well as their tools. Essentially, the manufacturing of any consumer good requires a large team. The provisioning of an essential software service requires a large team. All large teams suffer from the coordination problem, which can be defined as occurring when the marginal benefit of adding additional team members begins to taper off. Small teams are more directly additive or even multiplicative, but in large teams, somehow most of the work product vanishes, consumed by internal inefficiency. It is not really a surprise that this occurs, given our evolutionary legacy as tribal apes. We have invented a bunch of clever tech ranging from gyra to money to help us align incentives over larger structures, but it is still common to find organizations rendered permanently helpless by seemingly intractable internal problems. The thing I do not fully understand is that, for a large fraction of sharp, experienced engineers, it is completely natural to use the tools of engineering diagnosis and mechanical intuition to, for example, fix a car, but insanely weird to think of applying the same intellectual rigor to a machine composed of humans attempting to accomplish a common task. So my first ask is, for your entire work history, get analytical and suspicious about all the various kinds of organizational failures and search for systemic root causes. The CEO was an idiot may be true, but it does not explain how and why things actually go wrong. Certainly, it lends zero insight into how management, beset by these sorts of problems, actually must function. If you make it to the second round of interviews for a growth engineering role with a competent interview, they will be looking for evidence of this sort of insight. Why? Because candidates who understand it are almost guaranteed to intuitively understand their place in the value chain in an organization and to successfully integrate and quickly become productive. Conversely, an experienced candidate who lacks this insight is an enormous red flag and a harbinger of major trouble, since they will struggle to calibrate their priorities and actions. Second, stay curious about how humans actually interact in the real world. Collect examples. Read root cause analyses. Read memoirs by exceptional leaders. Of course, not every engineer wants to climb the management track, but there are two good reasons to understand this anyway. First, taking on managerial responsibility for teams and products extends your ability to bring about your vision of positive change in the world, as well as exposing you to a range of new and interesting challenges. And second, technical people take pride in the predictive accuracy of their modeling of the world. Your craft is incomplete if you are able to design and build fabulous widgets, but never understand why engineering always seems to be on the receiving end of pain from sales. These observations generalize to any other industry, though perhaps it is less natural for a non-engineer to examine process failures as though the organization is some kind of malfunctioning machine in need of repair. But it is valuable to respect, study, understand, and solve these problems. Doing so greatly increases team productivity, enhancing value creation and competitiveness, as well as making a more empowering and joyful workplace. My own journey to this sort of understanding began in ignorance. I was a mostly solo academic. Then I got curious about NASA's crewed flight failures and read their root cause analyses. But the observations remained parochial and unapplied within organizations in which I was a leaf node. It was not until I had the privilege of running a startup that the missing pieces of perspective helped to pull everything into place. If one gets nothing else out of management, this insight alone is well worth the hassle. Now I understand why the early career engineer can get disaffected. His boss asked him to perform a task, he worked his heart out and solved the assigned problem in record time, just how he was trained in school. But he did not understand the context of how that task fit into the big picture, and so when the result of his work product was, for reasons beyond his control, unintegrated from the product, he naturally felt that his hard work was not valued and began to slack off, form pity party complaint groups with other disempowered staff members, and forget that he is there to learn and succeed. Value flows in two directions through the organization. The customer buys your product, which brings them joy and value, and their purchase funds the operations of the company, which include sales, marketing, accounting, human resources, and other operational roles in addition to engineering. In return, each team's function works towards safeguarding and improving the value of the product. The measure of an engineering team's success is not how much they sweat, but how successfully their product meets the needs of the market. It is almost uncomfortably consequentialist. It is easy enough to focus myopically on short-term goals and local problems, but seeing the big picture will greatly improve anyone's ability to correctly intuit the appropriate application of effort to each of their various tasks. Enough rambling. The elite engineer has mastered their craft and has also mastered the construction and maintenance of an effective team composed of unique individuals. The value of the elite engineer is multiplicative between their various skills. Complete neglect of any one of the half-dozen or so expected core competencies greatly erodes competitive advantage on the hiring market. Get curious, read books, look around, and build awesome hardware.